G'day and welcome to the second video on related rates, which is exercise 6.6 in your textbook, one of my favourite parts of the course. Here's another question I've grabbed from an exam. So water is being poured into a cylindrical vase at a rate of 8 centimeters per cubic centimeters per second. The height of the vase is double the radius. Okay, find V, the volume of the vase, in terms of H. So essentially what we've got is something that looks like this. Okay, and we know that the height is actually double the radius. Okay, so if this is the radius, I know that the height is actually 2 times the radius. Okay, so when I'm trying to work out the volume of this thing, it's a volume of any cylinder is pi r squared height. But I also know that H equals 2r. And here it says find the volume in terms of H. So I guess I need to find out what R equals. R equals H divided by 2. So now I can substitute R as H divided by 2 into this. So I get pi R squared, oh, sorry, not R. I get pi H on 2 squared multiplied by H. So essentially this volume is actually equal to pi H cubed on 8. That's the volume of this vase here. Okay, that's A. And then B, it says at what rate is the water level rising when the depth is 2 centimeters? Well, here's where I need my given, want, and need. Okay, so I'm just going to go down a little bit and I'm going to write given. What am I given? Well, I'm given this rate up here, 8 centimeters cubic centimeters per second. So I'm actually being given dV dt because cubic centimeters is a volume. Okay, and what do I want? Well, I want at what rate is the water level rising? Okay, so I actually want dH dt because that's the rate at the water is rising with respect to time. And I know that dH dt is actually going to be dV dt multiplied by something. What is it going to be? Well, dV needs to be on the bottom because it needs to cancel out with the top dV, and so therefore dH needs to be on the top to get to that. So I actually need dH dV. That's a little bit troubling. I know what V equals because that's what I worked out in the previous question. V is pi h cubed, or an eighth pi h cubed. So I know that dV dH is actually equal to 3 on 8 pi h squared. Okay, or another way of writing that would be 3 pi h squared on 8. Now I don't want dV dH, I actually want dH dV. So what I can do is I can actually flip those two over and find out what dH dV is. And so I'm going to do that now. dH on dV is actually equal to 8 on 3 pi h squared. Now, back to my actual question. I want dH dt, and I know that dH dt is equal to dV dt, which is 8 cubic centimeters per second, which is what they told me before, multiplied by 8 over 3 pi h squared. You don't substitute h in until the final step. Okay, so don't be thinking you need to substitute h in up here or anywhere else because it changes with respect to the height. I actually want to find it out after I've put it all into the equation. So I get 64 over 3 pi h squared. Now I put in what my h value is, and this one says when the depth is 2 centimeters, I can find out at what rate the height is increasing. So when h is 2, I'm going to get 64 over 3 pi and then h2 4, so 12 pi, and then I guess I can just make that, what's that, it's going to be 16 on 3 pi, and that's centimeters per second. You don't actually need to write centimeters per second. In fact, just between you and me, I wouldn't write centimeters per second because if you stuff it up, you actually don't, get a mark for it. So they assume that you've got it in the right units, so that you know what you're doing if you leave it blank. So I would encourage you actually to leave it blank, 16 on 3 pi. Okay, so that's the rate at which the height is increasing for this particular question. Okay, so again, the nuts and bolts of this is you need to have the given, the want, and the need, and you don't substitute the H in until the very last step, and then you can find out what the actual answer is that you're looking for. Thanks very much.